For nearly 2 million years, the equation for cooking was simple. If you wanted a hot meal, you needed fire. It is a connection deeply wired into our DNA. The sight of a flickering flame signals warmth, safety, and food. Because of this history, many of us still hold a common belief that a real cook needs a visible flame. We assume that gas is the professional standard, electric is the clumsy alternative, and induction is just a fancy, expensive version of electric. But what if I told you that the professional choice is actually the least efficient way to cook? Or that the technology we consider futuristic comes with a strict set of rules that might force you to throw away your favorite pans? Today, we are stripping away the marketing and looking at the physics. We are exploring the evolution of heat to find out which method truly reigns supreme and which one demands the most compromises. Welcome to this episode of Simple Things Surprising Histories. To understand the kitchen, we must start with the incumbent champion, gas. The gas stove became a household staple in the late 19th and early 20th centuries, replacing dirty coal and wood stoves. Its appeal was, and still is, visual feedback. When you turn the dial, you see the flame grow. You know exactly how much heat you're applying. It is intuitive. But mechanically, gas is surprisingly primitive. It works by releasing a combustible fuel, usually natural gas or propane, mixing it with oxygen, and igniting it. This creates a chemical reaction that releases heat. However, from a physics standpoint, gas is incredibly wasteful. When you cook on gas, you're heating the air around the pot just as much as the pot itself. In fact, gas cooking is only about 40% efficient. That means for every dollar you spend on gas, 60 cents of it is literally floating away into your kitchen, heating up your house rather than your pasta water. Furthermore, we're learning that this open combustion comes with a hidden cost: indoor air quality. Burning gas releases nitrogen dioxide and other particulates that can linger in your home. So while gas offers that satisfying primal connection to fire, engineers realized decades ago that burning things indoors wasn't the endgame. They needed a way to generate heat without the flame. To solve the inefficiency of the open flame, the world turned to the defining power of the 20th century: electricity. Traditional electric stoves, whether they're the old exposed metal coils or the smooth ceramic glass tops, operate on a principle called joule heating. It works like a toaster. You send an electrical current through a metal alloy that resists the flow of electricity. That resistance creates friction on an atomic level, generating glowing red heat. This bumped efficiency up to about 74%, a significant improvement over gas. But electric cooking introduced a new problem: thermal inertia. If you've ever cooked on a traditional electric stove, you know the frustration. You turn the dial to high and you wait. The electricity must heat the coil, which must heat the glass, which finally heats the pot. Then, when the pot boils over and you turn it down, it keeps boiling. The glass retains the heat and releases it slowly. It feels sluggish and unresponsive. For decades, this was the trade-off. You could have the speed and control of dirty gas or the clean air of sluggish electricity. But what if you could force the cookware itself to generate the heat, skipping the middleman entirely? This brings us to the third contender: induction. Here's the surprising history: induction cooking isn't new. It was actually unveiled at the Chicago World's Fair in 1933. Back then, it was a scientific curiosity. Induction works differently. Underneath the glass surface, there's a coil of copper wire. When you turn it on, it creates a rapidly changing magnetic field. This field does nothing to the glass. However, if you place a pan made of a magnetic material on top, that field induces eddy currents, swirling electricity inside the metal of the pan itself. These currents create friction, generating heat instantly. The stove doesn't heat the pot heats itself. This makes induction roughly 90% efficient. It's faster than gas and offers even more precise control. But if induction is so fast, so clean, and so efficient, why hasn't it replaced every stove in the world? The answer lies in the limitations of that very same magnetism. While induction feels like magic, it's picky magic. Because it relies on magnetism, it requires ferrous cookware. That means your aluminum non-stick pans, your expensive copper pots, and your traditional clay vessels are useless here, unless they have a special magnetic plate added to the bottom. If a magnet doesn't stick to your pan, it simply won't cook. Then there's the issue of noise. While gas has the whoosh of the flame, induction has a sound known as the hum. Because high-powered magnetic fields cause the layers of metal in your pans to vibrate on a microscopic level, you can often hear a high-pitched buzzing or clicking sound. It's not loud, but for some, it breaks the silence of the kitchen. And finally, despite the technology, the surface is still glass. Unlike the heavy iron grates of a gas stove where you can bang pots around, an induction top is fragile. You can't slide a heavy cast iron skillet back and forth without risking a scratch or a crack. So, induction demands a change in lifestyle, new pots, a gentler touch, and a higher upfront cost. So when we look at the timeline of cooking history, we see a clear evolution of trade-offs. We started with gas, which gave us the ultimate control, but at the cost of wasted energy and indoor pollution. We moved to traditional electric, which cleaned up the air but slowed down the cooking process. And finally, induction, which offers the best performance and efficiency of all, but demands that you play by its magnetic rules. While gas will always hold a nostalgic place in our hearts for its visible flame, the science suggests that the future of cooking is magnetic, provided you have the right pots and pans to handle it. I hope this cleared up the differences between the three titans of the kitchen. If you enjoyed discovering the science behind your stove, please like this video and subscribe to Simple Things Surprising Histories. We have many more stories about the everyday objects you take for granted waiting for you. Until next time, keep exploring the simple things.